In this video, we will talk about characteristics, which is a very important topic in finite volume method. In previous video, we saw that if we have advection equation, then this advection equation has a solution, and that solution is just translated towards right or towards left. For example, I show you the animation first. For example, here you can see that the wave is traveling towards right. This is another animation. The initial wave is traveling towards right. So it means that the advection equation just translate your initial profile towards right or towards left. Suppose we have Q is equal to temperature, and this is the advection equation for temperature, and there is initial condition given over here. On the right hand side, you can see that there is an image. On the y-axis, we have temperature, and on the x-axis, we have x. The initial profile when t is equal to 0, like this, when t is equal to 0, we have some temperature profile like this. What advection equation does, it just translates this temperature towards right when u is greater than 0. So the solution will be t xt, the initial data will be transported towards right if u bar is greater than 0, and we have this equation. It is similar to the car moving in any direction. If we have a car, and if you want to see a distance in another place, for example, the same car, I made it differently, then how you measure the distance? You just measure s is equal to vt. The car remains the same, although it in this figure it doesn't look same, but it is the same. So it just covers a distance. So s is equal to vt. You can call it s minus vt is equal to 0, something like that. I hope you got the idea. Now, where characteristics come from, and what is the meaning of characteristics? If this quantity does not change, and it just translate towards any direction depending on u bar, which is the speed of the fluid or speed of the flow, then x minus u bar t remains constant. Okay, for example, if we have 2, any quantity 2, this quantity after some time will remain the same. X minus u bar t will remain the same. If the initial quantity is 10, then that quantity after some time will remain the constant. As you can see, when t is equal to 0, and here we have t is equal to 0, then x is equal to 10. Okay, so that quantity remains the constant. So we understand that. So one result is x minus u bar t remains constant. It means that if we use our notation q and that constant, for example, it is equal to x naught, some initial value, and x equal to x naught plus u bar t. So what is x over here? X is a function of t. X is a function of t since this x naught is constant. In one case it was 2, in another case it was 10, for example. That quantity just translate towards right. Now, what is the consequence of this equation? By the way, we call this equation as a characteristics. We will talk about that later on as well. Now, Q, which depends on x and t, it simply says that your initial profile Q tilde is just translated towards right if u bar is greater than 0. And from here, from this characteristics, we can say that x is a function of t. Now we take a derivative of q, dq by dt. Q is a function of x and t, and from this equation, we see that x is a function of t as well when we keep this x naught as a constant. We apply chain rule, partial q by partial t plus partial q by partial x dx by dt. We take a derivative of q with respect to x first, then dx by dt, and in another case it is partial q by partial t and there is no t dt by dt, something like that. So partial q by partial t plus, what is this term? This term actually speed u bar and partial q by partial x. And we see that this equation is equal to 0 since it is an advection equation. So what happened? dq, which is a function of xt comma t divided by dt, since we are taking ordinary derivative, the reason is q actually depends on t. These two are intermediate variables. So dq by dt is equal to 0. It means that q is constant. Why the derivative of some quantity is 0? There is only one reason that that quantity is constant. For example, if y is constant, if y is 2, then dy by dt will be equal to 0. It means that y is constant. So the interpretation of this quantity is q is constant, but the question is where it is constant. Since it is only constant due to this expression that we put it over here. It is constant when dx by dt is assumed as it is u bar, and u bar is the fixed velocity. And it is also zero since we also assumed that x of t is equal to x naught plus u bar t, which was actually coming from x minus u bar t is equal to constant. I hope you got the point. With some thinking, you can completely understand all these logics. So what was our question? The question was where q is constant. So q is constant when x minus u bar t was taken as a constant. Q is your solution, something like that. So q is constant when x minus u bar t is constant. This quantity, which I already explained, which is also a topic of this video, this quantity is called characteristics. Characteristics. So I can write this as well. This q like this: qxt is constant on along characteristics. Okay. Now there will be two graphs. One graph will be for q. On x-axis we have x, on y-axis we have q. Here you can draw the initial profile first. For example, as we already did this thing, you can draw any graph. And the another graph is, second graph is for characteristics. And the characteristics you will draw on x-axis you will take x, and on y-axis you take t. And what was the equation of characteristics in this case? It was x minus u bar t. This quantity remains constant, and the constant was x naught. For any x naught, let me just talk about that, since this is a bit difficult topic and not many people understand that from the books. Okay. For example, we have x is equal to u bar t and fixed value x naught. X naught can be any value on the x-axis. So the quantity, for example, density, mass, volume, not volume, maybe momentum, pressure, energy, will be on the y-axis in one case, and in another case it will be characteristics. Since on the y-axis we have t, and you remember from calculus, y is equal to mx plus c is the equation of line, and this is the equation of line. Whatever quantity comes on the y-axis will be on the left hand side. So if t is on the y-axis, so t should be on the one side. So it becomes tu bar x minus x naught, and t becomes 1 over u bar x minus 1 over u bar x naught, right? Here we say that when u bar is greater than 0, then this quantity, which is the slope of a line, it is similar to the slope of this line. So it means that when u bar is greater than 0, your characteristics will look like this. If this is x naught, which is in fact 0, then you have x minus u bar t is equal to constant. When we have another x naught, since it is moving towards right, then this is x minus u bar t is equal to constant for another x naught. There will be another x naught, for example, it will be 1, so on. And similarly, we have third value x naught is equal to 2, and then we have this characteristics. So all this information q actually travels on this characteristics. What is the meaning of that? If we have this characteristic, if someone is sitting over here and he or she speaks, then the person on this characteristic will only listen whatever this person is saying. So whole the information is traveling on these characteristics. Similarly, if another person is sitting on another characteristics and he or she says, for example, weather is good, then the person sitting on these characteristics will only hear about that thing. Okay, so that was the analogy of understanding characteristics. In next video, we will talk about the boundary condition, how to use boundary condition when we have characteristics. Thank you for watching.